Hello and welcome again to another edition of our Down and Dirty mini movies. We're up to video number 24 in our short film help series, where I just try to bring you a demonstration features of the TopCon product portfolio. I was asked to do a video on a one-point localization, just a demonstration of that, and be careful what you agree to, because once I got into that, I've come up with 5 scenarios. So this is GNSS one-point localization demonstration times 5. Now, number 1, we're going to be walking through a demonstration of a base rover one-point localization with a base receiver on a known ground coordinate. This is probably the number 1 way to demonstrate the product. Create a point number 1 or 1000, 5000, 5000 coordinates, and just start topoing on a scale factor of 1 to 1 on the ground. And your bearing reference is GPS north. Number 2, base rover one-point localization with base receiver on a known state plane coordinate. More survey related, your base is on maybe a Harn monument. Maybe you've done an OPUS solution previously, you want to occupy that and work on state plane. Great way to get started. Number 3, base rover one-point localization in a ground system, but your base is beginning just out in the open on an unknown coordinate. So this is basically the beginning of a multiple point localization, but you use this a lot of times when you shoot your first point. Maybe that's the only point you can find, and you do reconnaissance. It normally gets you close to the second point, and then you could add points and rotate in. Number 4, one-point localization back in state plane coordinates. Normally you don't think of localizing in state plane because in essence state plane is its localization within itself. But here you can set your base up in the wide open on an unknown point, topo a point in, and use the little icon here, correct base, and be back on state plane coordinate system, and you're doing a one-point localization. Number 5, switching over to a network correction where we only have a rover receiver getting TopNet live corrections in this example, and we're going to be localizing on a ground coordinate because maybe we just want to do a quick topo, stay on scale factor 1 to 1 on the ground, and take off on GPS north. Now again, all these are just demonstrations of different techniques for training lessons. Always revert back to TopCon e-learning. Professional Services has true training lessons here, and then they also have tons of great information on the My TopCon Now webpage, where you can get that from the apps. So let's get started. Well, the first scenario is the base rover one-point localization with a base receiver on a ground coordinate. So we're going to create a job with 1 point in the data collector. The base is going to occupy that, and we're just going to take off from there. So in Magnet Field, I'm running version 6.2. I am going to create a brand new job because I want to walk through 3 things to check on. I want to make sure my GPS configuration is for my base and rover. It's Hyper VR. That looks good. I want to make sure my projection is set to none, that it's not a state plane in any way. And then I'm not concerned what the datum is since we're working in a ground system. This could be NAT83 no trans or WGS84. I'll click next, and then I want to make sure I'm in US survey feet. That's all I'll do, so I will green check mark out. So to make a connection to my base receiver, and let's connect it. Now before we localize, I need to create a local coordinate to localize on. Now I can go to edit points and type that information there by clicking add, but just a down and dirty trick, if you're not concerned with a point number and want to save a little bit of time, just hit calculate and enter plan, and then you're done. Notice that it created a point number 1000 with default coordinates of 5000, 5100. So we have a point number 1000. We're going to go to setup, and we're going to start our base on that point number 1000. Now I cannot type point number 1000 in here and use it as a WGS84 location. I have to separate two locations, the local coordinate and the GPS WGS84. So I'm going to just leave this default name in here, base 1. It's going to occupy the WGS84 location. You normally would type in your antenna height, whatever that may be, and then you're going to measure in the autonomous latitude and longitude. This should be relatively close, within a couple of meters. Close enough for the corrections. So once we have that information, we'll start base. So it's going to be using that as a reference position to calculate corrections and transmitting it to the rover. So let's go to the rover connections and press connect. So it's made a connection to the rover, and it should update the base position. Might give us that warning. There it is. Next, we need to localize, because if you go to survey and topo right now, you're going to see just latitude and longitude that it would be storing. And you can localize now or you can localize later. It's not important. You can topo the whole job in latitude and longitude. But let's go to setup, localization. Notice that it's blank. There's nothing in here, so we'll click add. Our known point is a known point with local coordinates. That's the point number 1000. So we'll put 1000 in this first box. Our measured point. Now you notice here that you do have a icon to measure, but we will not do this in this scenario because we already measured that when we read in our base position, which is base 1. So all we do is select our known point and our measured point and just OK out. We have our information here. There's no residuals. And let's go back to the home screen. Now when you survey topo, you're on a local coordinate system. Let's zoom out real quick. And you're ready to topo with your bases of bearing of GPS north off of point number 1000. So scenario number 2, base rover, 1-point localization with the base receiver on a state plane coordinate. And again, this is if you're occupying a Harn monument, or maybe you have a Opus point that you've got coordinates on that now you want to survey some RTK on. So let's get started. So I'm going to begin again creating a brand new job and go through those 3 settings like I did before. Job number 24 again, Hyper-VR base rover, I want to check. This time I'm going to set my projection up for Tennessee state plane. We've only have one zone here. And probably doesn't matter, but I will choose N8083 no trans on this one, just in case we jump over to a network correction. And US survey feet. My display is going to be grid coordinates. Everything else we'll leave alone, and I'll hit OK. So here I want to begin by editing points, and I'm going to add point number 1, and I'm going to type in the northing and easting and elevation of my coordinate value. So I'm going to go to my Opus report, and I'm going to paste in the northings and eastings real quick. Now this is in meters, my job's in US survey feet. So when you paste this in here, just put an M after it, for example, and then when you tab, it will automatically convert that to whatever settings you have, which was US survey feet. Same thing here, meters, tab, my orthometric height in meters. We'll cut and paste that into here. So we'll click OK. So I have point number 1000 with my state plane coordinate values. So we'll go to connect to my base receiver. We make a connection. Now what's different about this, we have our point that we want to occupy with the base receiver. So I'm going to go to Setup. I'm going to Start Base. And here I am going to choose the point that has the state plane coordinate values on it. Now once I have the projection set up, it automatically populates the coordinate values here. It does the transformation in the background for me. So I just need to verify my antenna height is measured correctly. We don't and cannot read in a position. All we do is start the base on this information here. Base started successful. Go to Rover connection. Click Yes. Connect to your Rover. Should get the message popping up here in just a second that the base station was updated. Now when we go to Survey, Topo, we're measuring in state plane coordinates, and we're on grid azimuth and grid distances based on this point number 1000 that we began with. So next, scenario number 3, base rover 1-point localization with the base beginning on an unknown location. Now, as I said earlier, this works good if you're wanting to maybe you only have one point to localize on and you want to reconnaissance in some other points, try to find them. This works really well, but it's also the beginning of a multiple point localization. So I'm going to begin again by creating a new job just to make sure we have our settings set properly. Job number 24. This is a Hyper VR based rover. We're doing a localization, so I'm going to set our projection back to none to be on a ground system, and I'm not concerned with the datum. I'm in US survey feed, and my coordinate display is in ground. Next, to this particular job, I'm going to exchange from a file and bring in some points that are in a commented limited text file that is my control. Name, northeast elevation, and description. Next. Next. And then I have my 22 points imported. We can go to Edit, Points, and take a quick look at that. Now I have found point number 13 that I want to localize on. So that's going to be my first 1-point localization. It's going to basically take off on GPS north off of this point, and then I can navigate to these other points. So I'm going to go to Connect to my base receiver. It's setting out in the open, not on any point that's in the job at this time. It's going to be a new coordinate point. It's just out in the open. So the base is set up. We'll connect to it. We'll go to Setup, and let's start the base. Now again, the base is on an unknown point at this time. So we'll just leave that at base 1. Measure your antenna height like we've done before, and let's read in an autonomous latitude and longitude for this new point. You can stop it and start the base. Go right to our Rover connection. It's going to connect to my last Bluetooth device. We'll click Connect, and then I'm going to wait patiently till I get the error message that the base corrections have been updated. Alright. Now I want to go to point number 13 with my rover and localize on it. So I'm going to go to Setup. We'll go to Localization. Localization is blank. We'll click Add. My known point is number 13. My measured point. Now I could, like I did in another video, put in point number 13, store this. It would give me a warning. I could store it as a checkpoint and then only have one point number for this location. The problem is if you make a mistake and maybe you're really occupying 14 and not 13, you don't want to have an option to be able to fix that. So normally what I would recommend doing is call this one GPS 13. Yes, we're going to have two locations, but this is the ground coordinate. This is the WGS 84 measured point. Physically take the rover to point number 13, put it on the PK nail, plumb it up, go into this measurement mode, and then down and dirty, I'm just going to take a quick shot on it. So we've measured that, check OK, and now we have a 1-point localization on this point. Now before I get out of here, if you want to do an add, to add more points, take your rover to them, you can do a multiple point localization. We'll go back to the home screen, we'll go back under Survey, Topo, and now I'm right on point number 13 on this location. And I have the local coordinate values here. Now if you want to go back to the home screen and compare those coordinates, we'll just take a quick look. Point number 13, 5678.434, 5678.434 for GPS 13. This is a entered point, this is a measured point. So scenario number 4, base rover 1-point localization, known state plane coordinate, using the correct base functionality. Now this known state plane coordinate is going to be a topo shot that we measure with the rover. The base is on an unknown point, out in the open, maybe we couldn't occupy it, so we're going to do, in essence, a 1-point localization. It's not normally thought of as doing localization to state plane, because state plane is its own localization at WGS 84. That's a whole other scenario, so you normally don't think of it. But there is a way to do, in essence, a style of 1-point localization. And let's get started. So again, let's create us a brand new job so we can verify our configuration. Base rover, yes. Projection, you do want to set your state plane projection you will be using. We will set this to NAD83 node trans and got our geoid model. We'll click Next. US feed is good for me, and I'm in grid. That's all I want to check. Now before I set up the base and rover, I want to go to Edit, Points, and I'm going to add the topo shot. Well, it's not the topo shot, it's going to be the monument that I'm going to take the topo shot on that has state plane coordinates, which is point number 1000. So I will paste the northing, easting, and elevation from my Opus report for that coordinate point. So I'll finish pasting in my coordinate values and then click OK. So we have our control point that we're going to localize on, that we know the state plane value for. Next, go to connect, and we need to connect to our base. Once we're connected, we go to setup, and we're going to start base. We're going to put the base on an unknown point out in the open. It will not get run over, and it's just a good location. I'll leave the name as base 1. I'll modify my antenna height accordingly, and I'm going to read in, and this is an autonomous state plane position. It's close, but it's not the true position. It's just autonomous. Normally you see a latitude and longitude, but because we're doing it where we're setting the grid system up, you're seeing a state plane position. So once you have that autonomous position, start the base, then go to the rover connection. The rover's been running, tracking satellites. We'll connect to it, and we're ready to do the next step. Here we're going to, after we catch this information, go to Survey and right into Topo. Now this position is our topo shot. We got a fixed point, but this is not localized yet. This is still based on the autonomous base position. So I'm going to go to here. I'm going to change the point number that I'm going to be measuring to next as point number 1000, but GPS. I'm going to topo a brand new measurement, and I'm going to measure on top of this point number 1000. I'll move the rod there, and then I will measure the point. All right, the next step, we're going to go back to setup, and we're going to do a procedure called correct the base. Our topo point, that's the point we measured. This is a measured point, point number 1000. And notice these coordinates are really within a foot or so. They're pretty close, but again, it's not localized yet. Our known point is point number 1000. Do you want to correct the base, apply these corrections for the base? Yes, we do. So the base station was updated. It's now on its proper location. So the remaining topo shots that we measure will be acclimated or localized to the coordinate values from here on out. Number 5, a network rover doing a one-point localization using ground coordinates. Now in this demonstration, I'm going to be connected to TopNet Live, getting a network correction, and this is just an example is that a person wants to go out there, put the rod down, and just survey on ground coordinates with a scale factor of 1:1 on the ground and your basis of bearing of just GPS north and go. So like the other 3 scenarios, I'm going to create us a brand new job just so I can walk through these few settings we want to verify. This configuration is going to be the TopNet RTK configuration because I'm going to be connected to the TopNet Live network. I'm going to be on a ground system, so I'm going to set my projection to none, and I'm not concerned about the datum. US survey feed, and make sure my display is in ground. So I'm doing a one-point localization on a point, but I'm getting the corrections from a network. So one thing I want to do is go to calculate and enter plan just so it creates a point for me down and dirty 5,000, 5,100, which is point number 1000. So I'm going to go to connect first to the TopNet RTK. Now it's going to try to connect to my Hyper VR receiver. As it makes the connection, I'm going to uncheck this and close this box. I'm going to try to do a network RTK, and by doing that, it's going to create a base station in close proximity to me, fictitiously I guess you'd call it. So that base station is created and updated from the network corrections around me. So I can close out of here. So right now if you just go to survey and topo, you're basically just latitude and longitude because we haven't localized. To localize, we'll go to setup. Now before I'm going to do that, I'm going to go to status and take a look. Yes, this basically created a base from me about 2.21 miles, and that's the latitude and longitude. But I'll go to setup, localization. There's nothing here in the box. We'll click add. Our known point is point number 1000. Now normally on measured points, I recommend you type in another number for the GPS position, let's say GPS 1000, but since there's no chance of me making a mistake, since I'm just putting the rod down and saying this point is going to be point number 1000 and this is the position I'm beginning on. So I will choose 1000 and measure that. Takes us into the topo screen, and down and dirty take a shot. Now 1000 already exists. I'm not going to override or rename it, but if I store a checkpoint in the database, it will merge the local coordinate with the WGS84 position, which is fine. I'll hit OK. So that is our localization. wherever I put the rod down and say this is point number 1000 at 5000, 5100. So I'll go back to the home screen, and now we're ready to survey and topo in a local coordinate system, scale 1 to 1 on the ground, and GPS north. So thank you for watching and your patience through all 5 scenarios of what I've come up with for 1-point localizations.